Operators. You know operators already. They're something from Learning Java. Now, this course is for you if you've never programmed before, or you've only programmed a little bit, and you have no idea what things like variables, methods, structures, classes, you have no idea what all that stuff means. In this course, I'm going to take you through step by step exactly what each of those things mean and how you can use them to create a program for your own needs. Now, you're here for Java, but what you're actually going to learn are the basic building blocks of most programming languages, such as C#, Swift, Objective-C, Kotlin, anything new and great, Python, PHP, etc. So you're not just learning Java here, you're actually learning to code. You're learning the fundamental building blocks that let you make anything from mobile apps to software as a service to websites, absolutely anything you can think of. So let's go through what you're actually going to do in this very short course. Here we start with a quite scary looking list of words that are probably not familiar to you if you've never programmed before, or if they are familiar, you might not know what some of these actually mean. So in this course, we're going to go through every single one of these, and once you have all of these, or even half of these in your mind, then you'll be able to create almost anything you can think of. So we're going to go through variables. Variables are just a way of storing things in memory. Then we're going to look at operators. You know operators already. They're something from maths. Plus to plus 2. Plus is the operator. Minus, divide, times, and a whole bunch of others that are programming specific. Then we have conversions. So in programming, we have, let's say, a number. But to a computer, it needs to know if that is a specific kind of number. Is it a number that's a word, or is it a number that's a number? And I know that might not mean anything right now, but you'll see why that's important when we get onto that. Then we'll look at comparisons. Comparisons are ways that we look at two bits of data, two variables, and we see if they're alike or if they're different, and then we do something with that. So a very simple example might be if I have two apples, one is red, one is green, a comparison would say, is apple 1 equal to apple 2? And the computer would say, no, because the colors are different. And that's a comparison in programming. Then we have loops. Loops are valuable to go through lots and lots of data round in a circle, pulling one row at a time from a big long list of data, and then doing something with it. Loops are everywhere in programming, and they're actually the biggest problem that we have as programmers in terms of making our programs efficient. So I'm going to show you how to run loops, what they're all about, and maybe give you one or two pointers to watch out for when you're running loops in your own programs. Then we're going to look at arrays. Arrays are just a fancy way of saying a list of items. It's an array. So I have 5 apples, and if I ran a loop over those apples, I'd pull out one apple at a time from that list and do something with the apple, like slice it up and eat it. Then we're going to have methods. A method is exactly what it sounds like. A method is just a way of doing something. So if I said to you, here is a method to make rice pudding. You get some rice, you put water in the rice, you add whatever else you need for rice pudding, you shove it into a pan, pop it into the oven, and out comes rice pudding. You would call that the method for creating rice pudding. So you might say rice pudding cooking method. That's simply a method, and we use them everywhere in programming. Then we have classes. You can probably think of classes as a blueprint on how to do something. So a class might be a recipe. By itself, a recipe just kind of sits in the recipe book and isn't a manifest thing yet. So you'll have a recipe for a chocolate cake. Just because the recipe's there, it doesn't mean that the chocolate cake actually exists yet. It's simply a way of creating chocolate cake. So what you do is you then follow that blueprint, that recipe, and at the end you have a chocolate cake. And that's simply what a class is in programming. It's a blueprint to create something. Finally, we have inheritance. And inheritance is something that we add on to classes mostly in order to have shortcuts in programming so we don't repeat lots of code. I won't tell you what those are now because you can see for yourself as you go through the course. So I'm very much looking forward to teaching you all these basics. And once again, once you have all these basics down, you'll be able to program the basics of pretty much any programming language you can think of. Jump onto Google and search for JDK. Then click the very first link that you see, which is with Oracle.com. Oracle maintains and develops Java. Now when you click it, it tells you you can download Java SE, and you want to make sure that you have the JDK selected. So if I scroll down, there are many, many different things you can download for Java. However, you probably only need to click the first item. Now on this downloads page, scroll down, and what we need is the Java SE development kit. So click Accept License Agreement, and over in Download, download the correct version for your operating system. So I'm running on a Mac, I'll get the Mac one. If you're running on Windows, you would probably get the Windows x64 if you're on Windows 10 nowadays. But check if you need the x86 or x64. Okay, you can also get demos and samples and downloads on this page, but don't worry about that for now. Simply get the JDK. Once you have the JDK, you've downloaded and installed it, preferably restart your computer so everything registers. Then we're going to get to the actual item we will be using to create our Java code. There are many IDEs or development environments you can use for Java, the most popular of which is probably IntelliJ or NetBeans. If you're making apps for Android, you would get Android Studio. But this is just a very simple, short section, so what we're going to use is something called Java. And Java is very simply a way of compiling a Java program without too much fluff inside the program itself. So it allows us to write code and then compile it. And it's a great way just to learn what to do properly. So head over to drjava.org, click on the main page, and we want to download this jar file. Go ahead, click that, and once that's done, I'll use the direct link here. Once that's done, we'll look at how to run it. And there we have our downloaded jar file. If you double click it on a Mac, you won't be allowed to open it. So what you have to do is right click, then click open, and then bypass the security. Click open. You only have to do that once, and then OS X will trust it in the future. If you're on Windows, you should have no problem simply running that jar file. Right, that is Java installed, and we are ready to go. One final thing is that down at the bottom, inside of compiler output, it tells you that you have Java installed, and you have a compiler ready. If you get errors here, then simply go onto the Java website and see what people say concerning how to fix them. Now, if you are completely new to programming, it might be a little bit of a mystery to you. Why do we do it? What's it for? Well, programming is mighty simple to think about if you think about Lego. Lego is comprised of different sizes, colors, and shapes of bricks. They're all little individual pieces, and by themselves, they don't really mean anything. But what you can do as the builder is create items out of all of those blocks, and you can create pretty much anything you can think of. So that, in a nutshell, is really what programming is. It's taking all of these little tiny blocks and manipulating them, sticking them together to get them to perform a certain function. Like, for example, we've created a working house. So, in this section, I'm going to teach you some things about programming. Whatever language we're doing it in doesn't really matter, but I'm going to teach you the correct way of handling all of those little blocks and how to put them together into things that perform a much larger action on a much grander scale. Welcome to this very first lecture on Java. In here, we are actually going to start creating our first Java program. So open up Java and let's create something. Let's first look at how a Java program structures itself, because you can't just jump in and start writing code. The first thing you're going to see when you see a program is something along the lines of public class my thing. And then you'll see this strange bracket, which is called a curly brace. And you'll see another curly brace that matches up to it further down. So in programming, these are an opening and a closing brace. Now, what do public class my thing mean? Well, public in programming generally means this thing that I'm about to write is available to other parts of my program. So public means exactly what it says. It's public. Then class tells our program, or our computer, that this thing we're about to write is all contained inside of what's called a class, which is my thing. A class you can think of as a big storage box that you can put anything into. Okay, now we have our class, and how does Java know what to do or where to start? Well, every application needs what's called an entry point. And the entry point takes the form of this: public, static, void, main. And there's some more to write, but first I'll explain what we have here. Public, you know about. Static means that only one of these things can ever exist in programming. Now, don't worry too much about what that means right now, but static is a helpful way of telling our computer, hey, this is where you should come to start the program. And what does the computer do? It looks for a static main. So it says, oh, I found one. This is where I'm going to start the program running. We won't worry about void for now. I'll explain what that does later on. Then inside of main, we have something called a string. And we have two square brackets, one after the other, and args. And what does this do? Well, we're going to get into that much later, but for now, you can just think about this as a little bit of information that gets passed over to our program when it starts. And then what we do here is open the curly brace, and we close the curly brace. And you'll notice Dr. Java highlights with green the area between those braces. Now this is a simple Java program. How do we know this? Well, if I first save this somewhere, and in Java, you need to call your file, my thing, the same name as the class name. Otherwise, it throws a wobbly. So I'll just save this on my desktop. And now we have over on the left-hand side, mything.java file. Over on the right, we can hit compile. And down in the bottom, there's a box that says compilation completed. That's good. That means everything works as we expected. So Java recognizes everything we've written as a valid and legitimate program. Thing is, it doesn't do anything at the moment. So let's make it do something. Inside of the public static main, let's have system.out.println, and that's ln, and type hello me, or put your name there if you like. And that is a circular bracket before there and a circular bracket at the end. And then we have this text, which is between two quotes. Now I'm going to compile this, and I'm going to save the files. Then I'm going to click Run, and down at the bottom of Dr. Java, it tells you we are running my thing, and it gives us this green text called Hello Me. And this is what this line does. Our system.out.println will send us back some text. So that's really the very basic first Java program that you write. We have this thing called a class that holds all of our bits and pieces. Then we have this thing inside of that class that tells Java where to start our program. And then inside of there, we have some instructions that do things for us. And in this case, we're simply printing out some text to ourselves. Now try and remember this lesson very well, because this whole class thing and the entry point of the application is very important and universally applicable to all your Java programs. Welcome to this lecture on variables in Java. Last time, we created our basic Hello World program in Java, and we learned that we create a class and we put code inside of that class. We also learned that this public static void main gets called as the first part of our application, or the entry point to it. Now, let's remove this system.out.println, and let's just leave main. I'll create a bit of space in here, and we first have to talk about variables. What is a variable, and why would you want to know what it is? Well, the why is easy, because variables are the smallest building blocks of all programs. They're like the really small, tiny Lego pieces that you stick in key places in your models. What are variables? Variables are basic pieces of information. Now, I can say to you, here is number 9. Remember the number 9, and you remember it. If I ask you to write the number 9 down, you can write it down. If I ask you to put it in your phone, you can do that too. But the thing is, with programming, we can say to it, remember the number 9, but we have to tell it what kind of thing the number 9 is. And that is the essence of a variable. It's a kind of thing. So let's start with our number 9 example, which is called integer. An integer is simply a whole number, like 1, 2, 3, 4, or -4, -36. And the way we declare a variable integer in Java is by typing int, and then put a space in, and then we type the name of the variable. So let's just call this the letter A, and if we want to make it equal to something, we can type equals 9. And then in Java, we put a semicolon at the end of our line to indicate it has finished. Now our program holds this variable A, which has 9 stored in it. Of course, you can do the same with int B is equal to 10. Let's hit compile, and everything compiles nicely. There are no errors. Now, what if I want a decimal number? Well, let's try int C is equal to 9.87. Now hit compile. Ooh, and we have an error. And whenever we hit compile inside of any IDE, what we're doing is we're asking the program to translate this to code that can be run and interpreted. And if it finds a problem, it will tell you. And this is good, because you don't want problems to happen when someone else has your code, because when that happens, your code crashes and the whole program gives up. So it's much better to find your errors now. Right, down at the bottom, we have possible loss of precision. Required int found double. Okay, what does that mean? Well, this is a pet peeve of mine, and it's that whenever we compile things, it gives us cryptic messages if we are beginners. If you're an experienced programmer, then this is no problem to understand. What this is saying is that the integer c on this side cannot hold something with a decimal point in it. It can only hold a whole number. So it could hold 987, but it cannot hold 9.87, because integers are simply whole number stores. So how do we get around that? Well, we can change int to something called a double. And a double, if I click compile, does allow us to store a decimal. There are many different kinds of ways of storing numbers in your programming, and each of them has their limits. If you're doing really big maths, you probably want to try a double or what's called a long. Alternatively, if you have lower numbers, you can define what's called a float. Float d is equal to 9.86. Now let's see what happens if I compile. We have an error, and that's because floats need to have an f at the end of them. And when we click compile, everything works fine now. So always remember that doubles don't require anything added to the number. Floats require an f at the end. Now, whilst we're on the subject of numbers, what we're going to do is print out these numbers and see what our system says they are. So we want system.out.println. Open your brackets and let's output C first, and then let's copy that over, drop it in, and then output D. Now I'm just going to change D to 9.87, so these are nominally the same number. I'll hit compile and then run. And that's correct. They're both the same number. Now you may ask why I've done that. Well, in the subsequent lectures where I go into operators like addition, subtraction, and multiplication, you're going to see why I did that and why it's important to know what kind of numbers you're working with. Right, I'm just going to remove these system outlines and go over two more variable types that you really need to know about. The first of which is, what if I want to store something like a 1 or a 0, true or false? Well, there's a special type for that, and that is called a Boolean. Let's call this E is equal to, and we define it by writing true or false. And these kind of things help us to keep track of the state of an application. For example, if I was playing music and I hit the play button, I would say Boolean is playing is equal to true, so I know my music is playing. If I hit the pause button, I would say Boolean is playing is equal to false, because the music is no longer playing. So these are very handy to help you keep track of what's happening. Finally, what if we want to store a word? Well, that is simply string f is equal to, and then we open up our quotes and put our word in, close our quotes and put the semicolon in. Now we have what's called a string. And a string holds a bunch of text for us. Now, one final thing before we end this lecture is we cannot mix these types of variables. So I cannot say integer g is equal to name, because if I try and compile that, I get this horrible error that says, hey dude, you can't put a string where I'm expecting an integer. And of course, this works both ways. So if I try to write string g is equal to 7 and I compile it, I have the same error, just the opposite way around. It requires a string, yet I gave it an integer. So just know you cannot mix and match your variable types. And this is called typing when we program. Not typing as in the keyboard, but it means that our variables have to stay or be put in a particular kind of box. Okay, that's pretty much all there is to these simple variables. There is a lot more as we go on through the course, and you'll see we can expand on this idea of variables, so stay tuned for that. But in the meantime, that is variables covered. Let's discuss one of my favorite topics in programming, which is operators. I know it sounds a little sad, but hey, I am who I am. These things fascinate me, and you're about to see why. Let's start with our basic public class called myThing, and inside of our public static void main, let's write some code. Let's have an integer a is equal to 10, and an integer b is equal to 11. Now, what is an operator? Well, it's simply something like addition or subtraction, multiplication, and division. So let's see what that looks like. Let's have system.out.println, And inside the brackets, let's have a plus b. And we want a lowercase b. Now when we hit compile, it should compile fine. And when we click run, we get a result out of 21. And that's what we expect. It's added a and b. What about subtraction? Let's compile it and run it. And we get -1. That's fine. Let's multiply, compile, and run. 110, which is also correct. Now, here's the tricky bit. What if I divide, compile, and run? We have a result of 0. However, 10 divided by 11 is more like 0.9 something. So what's happened here? Well, when we divided an integer by an integer, the variable type that we get back is also an integer. And if you recall, integers only store whole numbers. So what does the system do? It simply drops out the point part, which is a little bit inconvenient, you might say. Right, let's try with a double instead. Hit compile, and then run. And now we have our long number, 0.909090, etc., recurring. So that works with doubles. Now, if you recall in a previous lecture, I said we have to watch out for these types. A number isn't just a number. So let's see what happens if we copy these 3 lines, paste them below, and let's change these to floats. Floats, and let's call it C and D, and let's have C divided by D. Now, when we compile and run this, we might expect the result to be the same. But look at that. When we use a double, we have much more precision. When we use a float, we have less precision. So if your program or app is doing something maths-based, then you have to be very careful as to which kind of variable you're using. Because division, for example, and this is a prime candidate for errors, will just drop the decimal point of your number. Floats will give you a much shorter number than you expect. And doubles take up more memory to give you a longer number. So in the future, when you're making your apps, really think about these points. Right, I'm just going to remove some of these lines to give us some space. And what I'm going to do is define a string A is equal to ground. And let's make a string B is equal to is, and string C is equal to awesome, because I have to say it, no one else will. Now, we can add strings together. So I can say A plus B plus C. And when I compile and run this, it does what's called concatenation. And that simply means putting strings one after another. When we're concatenating strings, we can also add other strings on the fly. So my sentence has no spaces. I can add quotation, space, quotation, and after B, I can do the same. And this is going to add 2 spaces into my sentence for me. So you can add strings on the fly. As you might expect, you cannot subtract strings. You, of course, cannot multiply them, and you cannot divide them. You can only concatenate strings. You can remove strings from the end of existing strings, but that's more of an advanced topic, and you'll come across that bit by bit in your Java development career. So that handles operators inside of Java in a very basic sense. Here's a little homework to challenge you and test everything you've learned so far. What I would like you to do is put your age into a variable. Then I would like you to put your mother's age, or your father's age, if she doesn't like her age going out in your videos, into a variable. And then I would like you to add, subtract, divide, and multiply those 2 values and print out all of those 4 results in one go. So you can use all of the tools I've shown you so far to do that. I won't give you any answers for this because I think it's much better if you attempt this by yourself. And that, in one sense, is what you have to do when you're learning to program, is you have to challenge yourself like this without readily available answers, and you will learn so much faster. So good luck with that task. Converting variables in Java. Now, this is not something I'd recommend you do if you can avoid it, but sometimes you simply cannot avoid it. So what do I mean by conversion? Well, if we have a string A equal to 3, as a human, we can read that as a number, that's fine, but a computer cannot. So if we try to do something like int b equal to 4, and then we said system.out.println a plus b, I think you know what would happen if we compiled it and then tried to run it. Or maybe you don't know what would happen, because we have a result of 34. And what Java's done is assume that you want to convert this 4 to a string. So it's added 3 plus 4 in the string sense and given you 34. Now you can see how this would cause issues. So what we're going to do is try and convert our string a to an integer before we run our arithmetic. So let's try int c is equal to integer, and when we put the word integer in brackets like that, we're doing what's called casting. And we're saying take the value of a and cast it as an integer. Now this is something you're going to see around the internet, and it's not wrong in and of itself, but in Java at least, if we try and add b and c, if we try to compile it, we will get an error. So if you see this kind of thing around the internet, feel free to ignore it. What we have to do instead is say int c is equal to integer dot parse int, and then we give it our string inside of brackets. Then Java goes and does some clever calculations and works out that you can change this string to a number, gives you back the string, and now when we compile and run it, we get the correct result of 7. However, if I change my string to my name, I compile, we get no errors on compilation, but when I run it, we get this horribly long error here. And all that's saying is basically, hey man, I can't turn a word into a number because I'm not a magician. So that is how you can convert from a string into an integer. Now what if I have an integer or some other kind of thing that I want to convert to a string? Well, you will find that you can use a method called .toString. But there's a little trick here that a lot of beginners get stuck on. If we simply use it on the integer a that I've declared here, you're going to find that, let's say, string result is equal to a.toString. And you'll find this all over the internet. You'll try it out by compiling, and it will tell you integer cannot be dereferenced. Now, what does that mean? Well, basically, the error that you're getting is the fact that we do not have a toString method for this declaration of integer. What we have to do is declare this integer in the following way. Integer a equals 9. Now if we compile, it'll work because we now have access to the toString method. What if we have something like a double that we want to convert to string? Well, if we compiled that, it wouldn't work. So what we're going to do on the string result line is access the double class, which has the .toString method, and we pass it over the actual double that we want to convert. Now when we compile, everything compiles happily. So generally, inside these classes like integer and double, you will find a toString method that can grab a primitive variable. So let's try that with integer and change this integer class. Let's compile that. That also works. There are many other kinds of conversions, but look those up as and when you need them. For now, like I said at the start of this lecture, if you can avoid this conversion situation, then by all means do. Methods in Java. Now, methods is a generic programming term that means basically a block of code. And it's kind of a container for this block of code. You may not know it, but you've already come across what's called a method. This public static void main is a method. It contains a bunch of instructions that get executed for us. So why would we ever want to do things like putting our code inside of methods? Well, I'll show you why. Let's have int a equal to 3, int b equal to 4. Then let's have int c equal to 5 and int d equal to 6. Then, of course, we can have our integer result 1 is equal to 3 plus 4. Or rather, let's have a plus b. Let's have integer result 2 is equal to c plus d. So now we have two new numbers. One is called result 1, one is called result 2 that adds them for us. Now this doesn't seem like a lot of hard work, but what if we had 2,000 numbers and we wanted to add them all up between them. Can you imagine writing 2,000 numbers or lines of numbers and then 2,000 operations? Well, I bet you can't. And this is where methods come in very, very handy. So let's define a method before we see why it's handy. Underneath of the closing curly brace of our void main, let's have a public static, for now, void add numbers. And this is the name of the method, just like main is the name of the method here. And we're going to pass this over an integer called a and an integer called b. Then we open our curly bracket and close it. Now you may be wondering, how is this a and b related to this a and b? And the answer is they're not. Everything contained inside of a method is only referenceable by that method. That means only all of this code can see those integers. Any code inside here cannot see these integers. They basically don't exist as far as it's concerned. So I can have as many methods as I like, where I have an a and a b, and those a and b's won't get mixed up in inverted commas. They'll always be separate. All right, so we've created our method, and what do we want to do in it? Well, let's say int result is equal to a plus b. Then let's print out the result. System.out.println result. Now we can come back into our main method, and we can get rid of these two lines and simply call add numbers, which will ask us for two numbers. So let's have a and b, and let's have another one, add numbers of c and d. Now let's compile, everything's okay, and let's run. And down here we have our results printed out. So can you see the power of methods now? Instead of writing out the additions here and then the system print line, we simply said, go to add numbers and pass it these two items. So off it went, gave it the two items, which were added and then printed. So methods are a way of enclosing, first of all, a bunch of instructions we want to execute. And secondly, they're a great way to decrease the amount of code that you actually have to write. Now, there's a fundamental rule in programming that you should make as many methods as make sense, basically. Not as many as you can, but as many methods as make sense for your program. And you should name them things that make sense to humans reading it. So add numbers tells me exactly what this method does. One thing that very frequently comes up when programming, no matter which language, is the need to compare your variables or some kind of objects. So let's look at how we do that. Now in Java, it's a little different if you're from various other programming languages. And there are a few gotchas that you need to watch out for. And what I'm going to show you in this lecture is the more correct way to do things as of the latest JDKs. So let's have two integers. Integer a is equal to 9 and integer b is equal to 9 as well. And how do we compare these? We use what's called an if statement, and then in brackets I'm going to show you the older way of comparing things. If a is equals to b, open your curly brace and close it. And then inside of here we can have our system.out.println, and we will send ourselves an equal message back. So what this line does is compare a to b, and if they're the same value, and there's a bit more to it than that, but for now just think about it in that way, then I would like you to print out equal. So if we compile that and then run it, we now get our equal printed out. Now what if they're not the same? Well, we can have an else statement that goes hand in hand with if, and we open our curly brace and close it, and again we can have system out.println to tell ourselves not equal. And then let's change the value of b to be 93, compile and run. And now we get numbers are not equal. Now, what if we want to go the other way round? So we want to check if a is not equal to b. Well, this is simple enough. Instead of two equal signs, we have an exclamation and then an equal sign. And that simply means not equal to. Generally, in programming, when you find an exclamation mark, it means not. And so here we can type not equal exclamation. I really can't spell exclamation or equal. And if we compile and run that, we will get not equal exclamation. So that's how you check for equality and non-equality with numbers such as integers or doubles or floats. But what about strings? Well, let's turn these into strings and another string, and let's call this my name, and let's have the other one as my name. Now, let's try and compile this. That's fine. Run it, and it tells us that these strings are equal. Now, there's a little gotcha here. When we are programming in Java and we're using string equalities, we do not want to use this notation. Now, I won't go into why, because that doesn't really matter here. I'm simply trying to give you a jump start in the Java world. So when it comes to comparing strings, we should use a dot equals, and then in brackets, b. And what this does is get the actual value from b and compare it to the value of a. It may seem the same as with the equals equal signs, but in the background, it's not really. And to avoid errors in your programs, always use this notation for your string. So now I'll compile that and run it. And it tells us, oh, we have a slight error in my logic there, not equal, because I've changed the logic into equals instead of not. And let me put not equal here. Let me recompile that and run it, and they are both equal. Okay, now what if we want to check if these values are not equal, and then we want to add a further check down the line? Well, we can do something like this. So the first one says equal, and then underneath of the first if statement, we can have another else if. So we can check something else. And for example, we could say if a or exclamation a dot equals b, and that means a does not equal b, then we can perform another function. So system.out.println not equal, and then we can have an else that gives us a default statement or execution. Now what this is doing is comparing equals here, and then it's saying if this doesn't work out, then comes the next one, and if a doesn't equal b, then do this, but if that doesn't work out, then come down to this one. So it kind of goes down in a little systematic process, checking which one it should run, and you can have as many if-else statements as you like, all chained up together. So if I put grant2 up there, hit compile and run, I have not equal. So it skipped the first one, found this one is true, so it skips the rest of them. Now in this case, it doesn't make sense to have 3, because either they're equal or not, but in other cases, you will have a need for this. For example, if you're trying to compare some user input that's come back, and you want to compare 10 things that could come back, you would use something like this. However, it starts to get a little messy, and the program tends to run on if you have lots of if-else statements all chained up. So there's an alternative for comparisons in Java, and that is a switch case statement. So let's remove all of this if-else code. Let's also remove string b and create a simple integer a, which will be equal to 4. Now we can create our switch statement. So we do that by switch, open brackets, and we pass it over our integer. Then we open some curly braces and close them. Inside of those curly braces, we start to define cases. So if we have a case where our integer a is equal to 3, we put a colon in, and then we write some code to execute. So we put something like system.out.println 3. And then after that, and this is optional, we put a break statement, and that tells us to stop executing this case. We can also have a case whereby integer is 4, and we can put a system.out.println that returns 4. And of course, we can break out of that once it's done. So we can have as many cases as we like, and it's advisable to have a default case, and this you define by default, and this will be system out default, and then we break out of that one. So let's compile that, and then run it, and it tells us our system out is 4. So those are switch case statements, and if you ask me, they're a little bit neater, a little bit more organized than if-else statements, but those two methods together provide all of the comparison power that you need inside of Java. Arrays in Java. First of all, what is an array? Well, you can think of an array as a list of items that are stored inside of one variable or container or box, or however you want to think about variables. They're very useful because it's nice having a list of stuff that we can access using just one variable. You can imagine if we had 100 names we had to store, and every time we wanted to access a name, we'd have string A equals Grant, and string B equals etc., etc. Writing that 100 times is pretty painful. So that's where arrays come in extremely handy. So let's learn how to define an array. We do that by first typing the type of variable we're going to put in the array, and then we open a square bracket and close a square bracket. And this means we're going to have an array or list of strings. Then type my strings as the variable name is equal to, open your curly brace, and start adding the items that you want to have in your array. So word, me, whatever it is, loppy. And close off your line. Now we have an array with 3 items in it, all called different names or strings. So how do we access, say, string number 2 or 1 or 3? Well, let's look at that. Let's have a system.out.println, and we're going to print out from my strings. And the way we access a particular item in the list is by opening a square bracket and then giving it the number where that item lies. Now in arrays and in programming in general, the first item lies under index 0. So most programming languages use what's called a zero-based index. Item number 2 lies under 1, and item number 3 lies under index 2. So let's pull out index number 1, and we should get the word me transmitted back to us when we run it. And there we have it. So if you're not familiar with this indexing concept, if you only take away one thing from this lecture, it should be that indexing is zero-based as a general rule in pretty much every programming language you can think of. Right? We don't just have to have strings. We can, of course, create arrays of integers. And we will call this my ints is equal to, and we can pass it over any number that we like of integers, close off our brackets, and declare the line. Accessing the integers in here is the same as with my strings. There's one final thing we need to know about arrays that you'll come across very often, because when you have an array, you might want to loop through it until the array is empty. So one final piece of information you need to know is how long is my array? How many elements are inside it? The way you find that out, and I'm just going to do a system.out.println for this, is by accessing the array.length property. And that counts the number of elements that you have in your array. So in my ints, we have 6 elements. And then if I compile and run, we get the number 6 presented back to us. That's going to come in handy when we look at loops in Java, so we can extract all of the values out of an array. Knowing the length is also useful if we do something like accessing a certain element in the array. As long as we have the maximum length of it, we can make sure, using some careful coding, that the index never goes past the maximum element, because if it does, we will get some kind of error. And I'll just show you what I mean. If I change my strings to access element number 5, which doesn't exist, I'm going to compile, which is fine, then I'll run. And look, we get this red writing that tells us the array index is out of bounds. As in, hey man, you've gone past the line, and I'm going to crash now. So if inside of this system out statement, where we accessed element 5, we could also have something like an if-else statement that checked that we could actually access element 5. That's just a side note. So the main thing to take away from this lecture is the construction of arrays and the fact you can put different types of arrays together. Round and round we go. Loops in Java. Why do we want to know about loops? Because they save us a lot of time when we're doing things like traversing through arrays, for example. So let's see what a loop actually looks like. Well, one version is called the for loop. And if we open our brackets, we can say int I is equal to 0, semicolon, I is less than 100, semicolon, I plus plus. Open curly brace and close curly brace. So what does this do? Well, the first declaration is an integer called I, which we set to 0. So the loop starts with I equal to 0. The loop runs round and round until I is less than 100. If I hits 100, the loop will stop running. each time the loop goes around, we add 1 to I by using the shorthand notation I++. Let's see what that looks like. Let's have a system.out.print line, and let's feed ourselves back I, and compile, then run, and watch the bottom screen. We loop through 100 times from 0 to 99. So that's what a loop does. It goes round and round until some condition is met, and it stops executing. So now this is very useful if we have an array of stuff and we want to pass it back to ourselves. So string my strings is equal to open curly brace, and you can say something like word me grunt, then close it off. What we can do with this is say for string value, that should have a space, sorry, value my strings system.out.println value, and close off your brace. So what this loop is doing is saying every time you encounter a value or an element inside of my strings, print it out. And then when the loop goes round again, it grabs the next element in line. So it'll start on this one, the first one, go to the next one, and finish with grunt. And if we compile and run that, we first get the 100 loop, and then word me grunt. So this is a nice shorthand way of getting all of the elements out of an array. There is another way of creating a loop, and this is called a while loop. And what a while loop needs is a counter for itself. So in the same way as the for loop had this I counter, what we have to do outside of the while loop is define our integer I equal to 0. Then we create a while loop, and we say while I is less than 100, do the following code. So let's have our system.out.println of I. Then we need to manually add 1 to I each time we go round, I++. Close off our while statement. So now compile that and run it. And there we have our second result. So a while statement is handy when you want to check for a certain condition, but you have to be very careful with while statements. If you forget to do something, for example, the I++, you can compile your program, but when you run it, it's going to run forever because it is stuck in a loop. And that loop will just go on and on and on. So be careful of that. I'm going to reset my project and put in my I++ again. Always make sure you have an exit condition from any of your loops. Welcome to probably the most important lecture on programming you will ever take. So pay attention to this one because it will be useful throughout your programming career. We're looking at classes and objects. So let's start by creating a class. Just as a side note, we already have a class, which is this public class, myThing, but we're going to ignore it for now and take this from the beginning so we can really understand why we need classes and why they're just so useful. Let's create a new file, and let's right-click it, save the file as, and call it car.java, and .java will be added automatically for us. Now in Java, it expects your file names to be the same as your class names. So we're going to make a public class called car. Open our curly braces. Inside of this class, we're going to give it a few properties. And if you think about a car, it has a property called perhaps int speed and a string color. It will also need to have what's called an initializer. And a class in most programming languages needs to have this inside of it. An initializer is basically a method that kicks everything off in the class. We define an initializer by the word public and then the name of the class. There are no voids or statics here. Inside of the initializer, we're going to pass over some of the things that we might need. So we might pass over an integer speed and a string color. Then we open our curly brace, and what we're going to do is make this speed in the class equal to this one. So to do that, we say this dot speed is equal to speed. And this dot color is equal to color. And this passes over these items into our class variables. Then we close off our curly brace for the initializer. Let's make another method called public integer, because this will return an integer. And let's call it get speed. Open and close your brackets, open a curly brace, and return this dot speed. Close your curly brace. Let's do the same for color. Public get color, or rather public string get color, and return this dot color. Close your curly brace and close the class curly brace. So if we look at this from the 10,000-foot view, what this whole class does is define something called a car. It's kind of like a blueprint. And when we grab our blueprint and we create something out of it, the blueprint requires us to provide a speed and a color, so we can then apply that speed and color to the car. Then later on, we can also get the speed out of the car and we can get the color of it. So save that file and let's look at how we create a car out of this class. Back in mything.java, in our static void main, let's create a car called Toyota, which is equal to a new car. And this new car expects a speed, 50, and a color, red. So now we've created what's called an object. And this object is called Toyota, and its type is of car. It follows this car blueprint. We can create another car if we wish. Car Ferrari is equal to a new car with a top speed of 200 and color green, because it's kind of a different Ferrari. Now if we compile this, everything compiles fine. And we have two objects, a Toyota and a Ferrari. And each of those is different. So we can print out our system.out.println the Toyota.getColor. And we can also copy that and print out the same for our Ferrari.getColor. Compile and run. And we have red and green. So classes such as car.java are the blueprint for things that we will create. They are not things in and of themselves. When we do what's called instantiating, that is creating a new object from the class, then and only then do we have a thing or an object. And every time we instantiate that class, we can create a different object. So classes are very handy in terms of cutting down code and taking care of things that you need to define multiple times. You can create as many objects as you like out of a class. So that is the power of classes. Learn this lesson well, and if you've got the time, please go back and redo this lesson, because this classes and objects idea is absolutely fundamental to all object-oriented programming. Whether it's Swift, Objective-C, C#, Java, it doesn't matter. You will use this idea time and time again. Last time, in this little series, we learned how to create classes and objects, which I said was a fundamental part of all programming. So in our example, we have this class called car. And what we're going to learn is inheritance, which again allows us to cut down the amount of code we have to write. What is inheritance? Well, it's a way that a new class can absorb information from an already existing class. So for example, if I wanted to make another class called big car, I could allow it to inherit from this class. And let me show you exactly what I mean by that. Let's create a new file, right-click, save file as big car. Now let's create the class itself, public, class big car. The way we define inheritance in Java is using the keyword extends, and then the class that this extends from, so car. Open our curly brace, insert our public constructor, big car, open curly brace and close it. Then what we can do is we can add another property to this. So we can add, for example, a string size is equal to large. Then we can give ourselves an access method, public string get size, and this will return this dot size, and close off our brace, close off the class brace. So what this is doing, and make sure you save that, is it's grabbing everything it can from car. So it's grabbing all of these properties. It's giving them to big car, and then big car itself is adding a couple more bits and pieces to it. Now, for the sake of simplicity, I'm just going to modify my car.java so we don't have to pass over any arguments. And we remove all of these items in the constructor, and we simply make our speed equal to 80 and our color equal to whatever we like. Okay, once we've done that, let's check our bigcar.java and open up our mything.java. Then let's remove the Ferrari and simply have a new Toyota. Let's also construct a big car called a caddy is equal to a new big car. Compile that, and as long as it works, everything now works as it should. And what we can do is have a system.out.print line that allows us to get our caddy.get size. Compile and run that. Whoops, we have a slight error. Let's check our bigcar.java. We have our this.size, so I'm not sure what this is trying to do. We have a capital S in system. Compile and run, and it tells us a caddy is large. But equally, we also have a get color for the caddy, which is red. And that's because big car inherits from car, which gives big car all of these properties and methods accessible to it. So that is the beauty of inheritance in Java. We don't have to construct the wheel again or rebuild the wheel. If we have a class, for example, called vehicle, we can derive cars, trucks, and motorbikes from that class using inheritance. So my advice to you in Java is to use inheritance wherever it's possible and makes sense. That's important, that last one. It has to make sense so that anyone going through your code later on will understand intuitively what you are trying to do. So that is your very basics in Java lessons complete. Now, by no means have I gone over everything there is in Java, because if I had, you probably would have been bored by the course and put it down straight away. So I've just covered the absolute essentials that you will need when programming. And here's a quick reminder. You've learnt about variables, operators, plus, minus, divide, how to convert between variables, how to compare them. Then you looked at loops, arrays, methods, classes and objects, which in my opinion is the number one thing you should take away from this tutorial. And finally, we looked at inheritance, which was another way to extend your classes. So that's what you've learnt. Where can you go from here? Well, now you're set to go and do something like an app development course in Android. I provide a couple of those, and depending on which platform you're watching this, you can find them underneath the list of items that I'm teaching. You can also create Java-based desktop applications or web applications. So well done. Congratulations on completing this course. And if you felt like you learned something, then please do leave a review.